Why is /dev/rdisk about 20 times faster than /dev/disk in Mac OS X? According to the Raspberry Pi documentation, you can load your OS to a flash card with either /dev/disk or /dev/rdisk. Rdisk stands for raw disk. /dev/disk is a block-level device. Why would rdisk be 20 times faster? Using Mac OS. Note, in OS X each disk may have two path references in /dev. /dev/disk hash is a buffered device, which means any data being sent undergoes extra processing. /dev/disk hash is a raw path, which is much faster, and perfectly okay when using the DD program. On a Class 4 SD card the difference was around 20 times faster using the disk path.
From Man-Shutil. /dev/disk nodes are character special devices, but are raw in the BSD sense and force block aligned I/O. They are closer to the physical disk than the buffer cache. /dev/disk nodes, on the other hand, are buffered block special devices and are used primarily by the kernel's file system code. In layman's terms, /dev/disk goes almost directly to disk and /dev/disk goes via a longer, more expensive route.
The accepted answer is right, but it doesn't go into much detail. One of the key differences between /dev/disk and /dev/rdisk, when you access them from user space, is that /dev/disk is buffered. The read/write path for /dev/disk breaks up the I/O into page_size chunks, 4 kilobits on x86 and ARM, 16 kilobits on ARM64, which it reads into the buffer cache, and then copies into the user space buffer, and then issues the next chunk-sized read. This is nice in that you can do unaligned reads and writes, and it just works. In contrast, /dev/rdisk basically just passes the read or write straight to the device, which means the start and end of the I/O need to be aligned on sector boundaries. If you do a read or write larger than one sector to /dev/rdisk, that request will be passed straight through. The lower layers may break it up, e.g., USB breaks it up into 128 kilobits pieces due to the maximum payload size in the USB protocol, but you generally can get bigger and more efficient I/OS. When streaming, like via DD, 128 kilobits to 1 MB are pretty good sizes to get near optimal performance on current non-RAID hardware. The caching being done by /dev/disk's read and write paths is very simple and almost brain dead. It caches even if not strictly necessary, like if the device could memory map and directly transfer into your app's buffer. It does small, 4 kilobits/16 kilobits, I/OS, which leads to a lot of per I/O overhead. It does not do any read ahead or write behind.
It seems /dev/disk and /dev/disk works different for HDDs and SSDs. Wanna checked it for microSD card. Just wrote 2 GB disk image to SanDisk Ultra microSD 64 GB, this URL. Repeated tests several times, but results were stable, 17 MB/s for /dev/disk versus 20 MB/s for /dev/disk. Changing BS equals 1 meter to BS equals 16 meters gives absolutely no difference in writing speed. Writing to /dev/disk 2. Writing to /dev/disk 2. Then I decided to test reading speed, 26 MB/s for /dev/disk versus 87 MB/s for /dev/disk. Changing BS equals 1 meter to BS equals 16 meters gives absolutely no difference in reading speed. Reading from /dev/disk to reading from /dev/disk to
I know that this is an old thread, but other folks might be interested in the speed implications of what I've tried. I want to back up my internal SSD and my MacBook Pro 13-inch Retina, with a Silicon Power 1TB SSD, to an external USB 3.0 2.5 inches hard disk drive, wanting to capture both the macOS and Boot Camp partitions. My initial command line was. The results were a copy rate of 31.3 MB per second. This was just too long to keep me waiting. So, on the second attempt, the command line was using /dev/rdisk instead of /dev/disk significantly sped things up to about 98.4 MB per second. However, it gets even better. So, for the third attempt, I use this command line. The sparse option tells DD not to bother writing to output blocks that are all zeros on the input. What's cool is that this gets much faster than you'd think, even while in the middle of full areas of the disk. On any drive that isn't full, you'll have huge chunks of zeros, further speeding up DD. So far, at least, DD is just about running along at my hard disk's theoretical transfer speed, 116.4 MB per second, and it hasn't yet reached those large blank areas. Give these options a try, they work. Please note, carefully change if equals and of equals to properly point to the correct drives listed by, for Macs.
This is Visual Saving.